So far, we talked about the mechanism, direction, and the value of electric current. Now, it's time for us to understand the external factors on which this current on any conductor will depend. Similarly to these type of experiments, a scientist named Ohms gave his results. Let's try to understand that. What Ohms noticed that on which factor the current is actually depending. First of all, what he tried to observe the main reason of the electric current. We know that the current will only flow when we apply these electric fields. And electric fields can be provided only by providing the potential difference. Potential difference. Potential difference. This is something that you know from your previous lectures. Potential difference we denoted by V. What Ohms did, Ohms tried to observe that how the potential difference and the current are actually relating with each other. You can also understand with your knowledge. Try to see here. You know, in this particular animation where the current is flowing in the form of the electrons that are flowing opposite to the electric field, what if I increase this potential difference? Means if I put more negative charges here and more positive charges here, then what will happen? Obviously, by doing so, I am increasing the force by which I am pushing the electrons inside a conductor. By doing so, the current inside any conductor will also gonna increase. This he also observed by doing simple experiments. What he got that V, that is potential difference in any conductor, comes out to be directly proportional to the current, that is I. Now, to remove this proportionality sign, all of us know we just have to put a certain constant. So I'll be writing it as V equals to I R. R here is not constant. We call this R is nothing but electrical resistance. Electrical resistance. What this electrical resistance is? It's actually the property of any conductor that will oppose the flow of electrons through it. Thus, it is something that is bad for any conductor. If the resistance is more, then the current flow will be altered. And actually, the current flow is altered, it means the electrons will lose their energy more quickly. Now, let's try to understand some external factors on which this current will depend. Try to see this. If I increase the area, let's talk about the physical factors. So first I will be starting with this area. If I increase this cross-sectional area, what will happen? The number of electrons will gonna increase. And when number of electrons will gonna increase, obviously the amount of current will increase. Why? Because the amount of current I is nothing but Q by T. By increasing the area, I am actually increasing the number of electrons. Thus the Q will increase and the current will also increase. Now, see here. If I write this expression V equals to IR, I am increasing the current, but I am not changing the potential difference, which means that potential difference remains constant. To make this constant, I is increasing by increasing the area. Let me write out here by increasing the area, I am increasing the current, but the potential remains same. Thus, this R needs to be lower so that they both can maintain this V. So I can write it as that this resistance R, or the internal property of any conductor R, is inversely proportional to the area. Same we can understand with the help of length. If I increase the length of this conductor, what will happen? The amount of electron will remain same, but now each electron has to push the more number of electrons. As there are more number of electrons linearly, thus each electron will transfer their energy to more number of electrons. Due to this, the current will eventually decrease. As per unit time, the flow of electron will gonna decrease. So what I'll write, again writing the Ohm's law, that is V equals to IR. What I am doing, I am decreasing the current I by increasing the length, by increasing the length. Due to this, what will happen? Due to this, the resistance will increase. Thus, I can write that this resistance is directly proportional to the length of any conductor. L, the first relation we have, inversely proportional to the area. Length and area, these two are the only physical factors. Now, what if I combine them all? If I combine them all, I'll get R is proportional to L by A. Again, to remove this proportionality sign, we have to include one more constant. That will comes out to be R is equals to rho L by A. Now what this rho is? Here, this rho is known as resistivity. Resistivity of any conductor. Again, it's a internal property of any conductor that not even depends on the length and the area or the dimensions of any conductor. Now, what about the units of these new values that we have generated? The resistance has a unit that is known as ohm, 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 as it is given to us by the ohm by following his experiment, that is the Ohm's law, V equals to IR. We come to know about the resistance. What could be the unit of this resistivity rho? If I send all the things there, what I'll get, rho is nothing but R multiplied by A divided by L. So we'll get the unit as ohm meter. This is the unit of resistivity rho. Apart from these two properties, we also define two more properties, that is conductance and conductivity. It's nothing but conductance is just the reverse of the resistance, 1 by R. Conductivity is nothing but the reciprocal of the specific resistance, that is rho. I hope you understood these two concepts. Now, let us see the temperature dependence of this rho and R. These two terms will also depend on the temperature. As the temperature will change, the current in any conductor will also gonna change due to the change in their resistance and specific resistances. So, to do so, we simply have a relation that I'll just write it here for your reference. It's something like that. Rho is equals to rho naught 1 plus delta T. Means for certain temperature difference, we'll get this value of rho T. Here rho naught is known as the reference resistivity. If I try to draw a graph in front of you so that you can easily see the variations, what I'll simply get, if I have horizontal axis as a temperature axis and the vertical axis as the resistance or resistivity, you can see conductors, the resistance will eventually increase with temperature. For semiconductors and insulators, it will decrease, and for alloys, it will almost remain constant. Well, that's all for today. We'll again meet and discuss some more concepts of current electricity.